Look around at the natural world. You see curves, fractals, spirals, and branches, forms that are efficient, resilient, and beautiful. Now look at much of our built environment. You see boxes, right angles, and flat planes. For most of the 20th century, architecture was dominated by the machine aesthetic. But a powerful movement is changing that, an approach that seeks not to conquer nature, but to learn from it. This is biomorphic design. It's an architecture that doesn't just imitate the shapes of nature, but seeks to understand and emulate the underlying principles that make those shapes so successful. In this video, we're going to explore what happens when architects think less like engineers and more like ecologists, creating buildings that feel as if they were grown, not built. Before we dive into the stunning visuals, we have to define our terms because biomorphic is often used interchangeably with biomimicry, but there's a crucial distinction. Biomorphism is primarily about form. It uses shapes, patterns, and silhouettes found in nature, the curve of a shell, the texture of honeycomb, the flow of a river, to create an aesthetic that is organic and often emotionally evocative. It's inspired by the look of nature. Biomimicry, on the other hand, is about function. It's the engineering-level imitation of natural processes and systems. For example, designing a ventilation system based on termite mounds or a surface coating that repels water like a lotus leaf. A building can be biomorphic without being biomimetic and vice versa. But the most powerful designs, the ones we'll focus on, often fuse the two, where the beautiful, flowing form is a direct result of an efficient, nature-based structural or environmental strategy. To understand this evolution, we have to look at the pioneers. The godfather of biomorphism is arguably Antoni Gaudí. A century before the computational tools we have today, he was using physical models with hanging chains and weighted bags to discover natural, catenary curves, the same stable forms you see in spider webs and suspended vines. The result is the Sagrada Familia, a building that feels less like a constructed cathedral and more like a stone forest that has grown from the earth. He was literally letting gravity and physics design the form. Jumping to the late 20th century, architects like Frank Gehry began to explore more complex, fractured geometries, but it was the advent of parametric design that truly unlocked biomorphism's potential. This is where the real magic happens. Parametric design uses algorithms to generate forms, much like how DNA codes for the structure of a living organism. An architect doesn't draw the final shape. They design the rules and relationships, and the software grows the form. This is how architects like Zaha Hadid created masterpieces like the Heydar Aliyev Center in Baku. Its flowing, seamless curves aren't just for show. They create a continuous structural skin, eliminating the need for columns and beams and evoking the geological landscapes of the region. Let's break down some iconic examples and the natural principles they embody. First, the Lotus Temple in Delhi. This is pure, literal biomorphism. Its form is directly derived from the lotus flower, a symbol of purity and sacredness in Indian culture. The 27 marble-clad petals are arranged in clusters of 3 to form 9 sides, creating a structure that is instantly recognizable, serene, and deeply symbolic. Next, the Gherkin in London. This is biomimicry in action. Its geogrid exoskeleton is not just a stylistic choice. It's a highly efficient structural system that mimics the lattice structure of the Venus flower basket sponge. This deep-sea creature has a skeletal structure that provides immense strength with minimal material, exactly what's needed for a skyscraper. The building shape also promotes natural ventilation, reducing its energy consumption. Finally, the work of Santiago Calatrava. His structures, like the Milwaukee Art Museum, often emulate skeletons, wings, and bird forms. The moving, wing-like brise soleil isn't just a dramatic gesture. It's a functional element that opens and closes like a bird's wing in response to the sun, providing shade and managing solar heat gain. So, how do you actually build these complex, flowing forms? The construction of biomorphic architecture is a dance between digital and physical. It starts with a 3D model, which is no longer just a representation but a digital twin containing all the data needed for fabrication. This model is used to drive computer numerical control machines that can cut, mill, or form the unique components. For curved metal panels, this might mean using robotic arms to bend sheets into their specific, non-repeating shapes. For complex concrete forms, like in the Heydar Aliyev Center, you need to create custom, digitally fabricated formwork for every single unique curve. A pro tip from fabrication specialists: the key is rationalization. using the software to take the perfect, continuous digital surface and break it down into the largest possible buildable panels to minimize seams, waste, and cost. It's a constant negotiation between the ideal organic form and the practicalities of material and budget. The advantages of this approach are profound. Structurally, nature's forms are inherently efficient, using minimal material for maximum strength, leading to material savings and reduced embodied carbon. Environmentally, these forms can be optimized for passive solar heating, natural ventilation, and daylighting, dramatically cutting operational energy. Aesthetically and psychologically, studies show that biophilic design, incorporating natural forms and patterns, can reduce stress, improve creativity, and enhance well-being for occupants. However, the challenges are equally significant. The design and engineering require highly specialized skills and expensive software. The fabrication and construction are complex and often more costly than conventional methods. And there is a constant risk of the design becoming a superficial, stylistic gesture rather than a deeply integrated, functional solution. In conclusion, biomorphic design is more than a style. It's a philosophical shift. It represents a move away from the machine-age metaphor of the building as assembly of parts towards an ecological metaphor of the building as an organism integrated with its environment. It asks us to see nature not as a resource to be extracted, but as a mentor to be emulated. As our computational power grows and our climate challenges become more urgent, this way of thinking may not just be an aesthetic choice, but a necessary evolution for creating a resilient and beautiful built environment. Now I want to hear from you. What is the most compelling example of biomorphic architecture you've ever seen? Do you think this organic language is the future, or will the simplicity of the box always have its place? Let me know your thoughts in the comments below. If this journey into living architecture has inspired you, please give this video a like and subscribe for more content that explores the cutting edge of design.